Hello and welcome to another STEM in a Box instructional video. Today what we are looking at is using LaserWeb4 to trace a simple bitmap of a cut that we want to do. So let's start with making a simple rectangle cutout. So in Paint, which is the simplest situation you can use, you want to make the size of the line as small as you can and the no fill, and then just make any size rectangle. Okay, so we've got that there and we want to save that as a PNG. So we're starting off with a bitmap image, so save it as a PNG. So I'm going to save that as cutout. Yes, thank you very much. Great, so that's created my bitmap, my square. A rectangle doesn't have to be precise, we change it later. So let's go to LaserWeb4, and LaserWeb4 can do three things. It can process some of your artwork like we're doing today, and we are turning that into a bitmap into a vector. It can generate your G-code from your raster or your vectors into G-code, and it can also work as a host controller for your laser machine. So that's the three functions all in one of LaserWeb, which makes LaserWeb really awesome. Great, so you set your machine up there and get the communications going. Let's go and grab that cutout PNG that we did before. I'm just going to zoom in to the document you see. So that's the bitmap, okay? So we're not going, you can't do a cutout with a raster engrave. It won't work because of the way it works. It just zigzags and then fires whenever. It's just, you don't get the power. You need to turn it into a vector, okay? Great, so that's what we're going to do. That's the first thing we're going to do. So we want to select on it. Now the dialog box comes up down here. We want filters and trace, and I'm just going to turn smoothing on. So this is converting the bitmap editor, the bitmap image, into a vector trace. And let's just preview the trace. Great, excellent. So this is the vector on the right hand side. So I'm going to create it, and then I'm going to drag the bitmap across. So this is the bitmap on the right hand side, and this is the vector here on the left hand side. Okay, so how do you know what's what? Well, you can also hide them up here. So I'm going to hide my PNG image, so now you can't see it. And if we double click on that one there, you can see the SVG, which is Scalable Vector Graphics. So that's your vector path has been created. Okay, so that is the vector there. So we click on that. So then now we can change that. I'm going to say make it 100 by 100 exactly. So 100 by 100 in the X and the Y, and put it in the corner. Thank you. And there we go. Alrighty. So I'm just going to zoom out from that a little bit. So that is your vector right here. So that's now your square, which is exactly 100 by 100, and that's vector. Now this was done in Paint, so it's important that we recognize that the thickness of that line is very thick. If you're doing Paint.net or some other more advanced program like Illustrator or some sort of CAD program, you need to make the stroke width, which is the width of that line, very small, like 0.02 or something like that, and the reason for that will be evident in a moment. So that's second step. We've traced it and we've got our vector here now. So what we now to do is we need to drag our vector down into our G-code generation. Now I'm going to show you the problem first, and if we just do simple laser cut, that's fine. Do the cut rate, let's say it's thick cardboard or something, it's 200 power, 1 pass. Yes, that's all good, and I'm going to generate that, and then we can have a look on our simulator, and what we can see is we've got, that's it, goes around, it's got 1 pass and then it's got another pass. And the reason for that is that that line, because I can't make the line thickness any smaller in simple Paint, the laser is trying to, it's infilling that line. Okay, so how do I get around that? Well, if I had a proper, more advanced, graphics program, I would make the stroke smaller, like 0.02, but we can't do that because that's Paint. So what I'm going to do is change the settings here. So I'm going to just delete that altogether and go back to the beginning and drag that back in. And now this time, instead of laser cut, I'm going to do laser cut on the inside. You'll see now I have laser diameter, and I'm going to tell it that the laser diameter is 0.3 millimeters instead of the default, which is 0.1. And we're going to see if that works. It's a matter of getting the laser diameter to basically match the line width that you've got there. Laser power is 100, that's good. Cut rate 200, so let's generate that G-code now. And let's look at the simulation. And we've got one laser, one path, okay? So we've got one pass. So that's fine. So if you still had two passes, then you need to make your laser diameter bigger, but in Paint 0.3 works, okay? There, let's check the G-code out. And yes, that's good, one pass, and cut rate 200, fantastic. The laser's going on full power there, which is the S1 at a feed rate of 200, which is the cut rate. That's all good. So everything looks fantastic. So G-code looks good. So what you could do now is you could either save that G-code to a file on your SD card or to your network, and then go and put it on the EdLaser physically via the SD card, or if you've got it hooked up via the network, then you can just go and run your job here. Okay, great. Thanks for listening.